Hey guys, this is day 3 of the Pythagorean theorem. You should look for this note sheet first of all. Really, it's day 1 of this new part of it. I apply the Pythagorean theorem and its converse we're going to talk about today. What does that mean? First, just very brief recap of what we've been doing with the Pythagorean theorem. Pythagorean theorem says that if you have a right triangle, this formula works every time. A squared plus b squared equals c squared. And we know that c is the hypotenuse, as we've talked about, and a and b are the legs. And we talked about a couple different ways to set them up. Here's my right triangle, and just realize in each one which side you're looking for. In this case, again, now they've labeled them x, so you have to know, right, to be smart enough to know, okay, which side am I looking for? In this case, this is the hypotenuse, right? Because it's a side across from the right angle. So if I was setting this one up, it would be like 7 squared plus 8 squared equals c squared. Or again, I could use x, of course. Okay? But this other one, look at the other one I'm looking at. Okay, this one has the right angle here, and it's pointing across, and here's the hypotenuse, and it gives us 8, right? So that's c in this case. And then the 7 is a, and then this is like our b, and again, they've used the variable x. So this one would set up as 7 squared plus x squared equals 8 squared, and then I have to solve it from there. Again, small things, but just make sure you understand how we've been using the Pythagorean theorem so far. We're going to roll it over today, though, now into the converse of the Pythagorean theorem. What does converse, that word, mean? Anyway, go to that next note sheet. Again, this note sheet is attached to our lesson in the folder. You should print it off. Although if you don't have it, but otherwise if you do have it, then you're in luck. Otherwise, you can just take notes right along with on a blank piece of paper. Converse of the Pythagorean theorem is kind of like, in a way, as you're going to learn more in math, it means like the opposite if you switch things around, okay? This says, converse says, if I have 3 numbers that work in the formula, a squared plus b squared equals c squared, that tells me that those 3 sides must make a right triangle, okay? So it's kind of like we're trying to figure that out. We're still using this formula today when we use the converse, but now they're going to give you all 3 sides, and you need to put them in for a, b, and see if it works. And if it works, you have a right triangle. And if it doesn't, we'll talk about which type you do have. Now, when they give you 3 sides, they don't necessarily put them in the right order for you, but there is one in particular that needs to go in for a certain variable, and I bet you can figure it out. Just like we've talked about up here with the problems before, right? That hypotenuse, that longest side, is always the c. It's always the biggest one, okay, in the right triangle, because it has to be, right? It's across from the right angle. So when you're doing the problems today, they'll give you 3 numbers. Just make sure that you always make sure when you take the 3 numbers, you always pick out the biggest one to be c. So in this problem, it has to be 41. That has to be c for this problem. The other 2, it doesn't matter. A and b are kind of interchangeable. But c, if this is going to work, make sure you plug in the biggest number for c. So this would start to look like, and here's what your work will look like today. 40 squared plus 9 squared equals 41 squared. I put all the numbers in, all 3 of them, and I'm trying to figure out question mark. Okay, does this work or not? Is this true? Okay, again, you can use a calculator to help you, but I can help you a little bit right now. 40 squared is 1600. 9 squared is 81. And when I square 41, what do you know? I get 1681. And when I add these 2 together, I get that same thing, right? So 1681 equals 1681. That is true. So these 3 sides make a right triangle. That's what we're finding today. Okay, going to that 3rd slide. Now you may say, okay, that's great, but what if I plug in the numbers and they don't? A squared plus b squared does not equal c squared. What kind of triangle do I have? What if it's not a right triangle? Can we tell which type it is? And the answer is yes, we can. Just remember, we've had 3 different kinds that we've talked about when we define triangles by angles, okay? And I'll try to draw, but again, I'm terrible at drawing. So remember, here's a right triangle like we've been working with. Okay, there's a right triangle. Other types of triangles you may remember that are defined by angle is the obtuse triangle. That's where this biggest angle is too big, right? This is an obtuse triangle where the biggest angle is bigger than 90 degrees. And then there's acute triangles, very acute triangles, where all the angles are less than 90 degrees. So here's the 3 types, and we're going to find out today that either we're going to have this type or this type or this type when you're doing these problems, right? So let's see if we can figure it out. I've got a little visual here that'll help too. Let's start with this first one. Here's what problems might look like today. Tell if the triangle is acute, obtuse, or right by using the Pythagorean theorem. Here's our old buddy, the formula. A squared plus b squared equals c squared. Again, when you're doing problems today, you may want to go through right away and just label, like, okay, this is A, this is B, and the biggest one for sure is C. And I've set all these problems up nicely. So in this case, yep, the last one is always C, but it won't always be that case. But maybe when you do the problems today, as you look through the worksheet or the Schoology problems, you might just want to look through and say, oh, this one's C, this one, and just make sure you label C and then A and B for each one, just to make your life easier as you get to those problems, okay? So I've labeled them as such though for this, and I'm going to say 6 squared plus 8 squared, does that equal 10 squared? Again, I'm trying to figure that out, question mark. Is that the truth? Okay. So here's what your work will look like too, starting here. You plug the numbers into the formula, then you got to figure out what these squared are, and again, you can use a calculator, but these, I think a lot of these nice ones, or lower ones, you can figure out. These are our perfect squares. 36 plus 64 equals 100. And when I add these together, what do you know? I do get 100 equals 100. So this, you would say, is a right triangle. You'd enter that into Schoology, okay? Because it does work. Let me just put that over here now. So this, looking at this triangle, this is a right triangle. There's my right angle. And this could be the 6, 8, 10 triangle, okay? Now, before we even do all the math, okay, I'm going to go to problem number 2 here. But I'm going to get you to try to see how you could figure it out anyway, how this always works, okay? Take a look at this next triangle. It's almost the same as number 1, right? This was a 6, 8, 10. Well, this is a 6, 8, 13 triangle. So that C side is bigger, right? The hypotenuse now, as opposed to being 10, that longest side is 13. Maybe you can kind of guess. Pause the video if you want, but maybe you can kind of guess what's going to happen here as I plug the numbers in, and that should maybe lead you to your answer. But let's try it now. When we plug in the numbers, and I'll try to show you with a visual too. 8 squared plus, or 6 squared plus 8 squared, does that equal 13 squared? I'm trying to figure it out. 6 squared is still 36. 8 squared is still 64. 13 squared is 169. When I add 36 and 64 together, I get 100, which is less than 169. You should definitely get to a point in the problem like this, where you've added the numbers on the left and now you're comparing them. Like we said, C is bigger this time, right? It's 13 as opposed to 10. Imagine if this triangle now, as opposed to, look at my hypotenuse for this triangle. Let's say as opposed to being 10, for the blue case, now let's say it's 13. So it goes to here and then further out. I bet you can figure out, then let's pretend this is still kind of close to 6 and this is still kind of 8. That makes our obtuse triangle. I'll write a rule at the end of this for all 3, but notice what happened. The C, that longest side, the hypotenuse, when we squared it, that was bigger than A squared plus B squared. That was bigger than the other 2 added together, okay? So when that is bigger, when C is bigger than the other 2, that's when you get the obtuse case, all right? Let's do this last one, and look how we've set it up. 6, 8, 9. So that's a 6, 8, 9 triangle. The one that worked, that was a right triangle at the top, was a 6, 8, 10. Now it's 6, 8, 9. So that longest side is a little shorter, right? I'm going to draw it over here on the picture first this time. Let's say this is 9 inches instead. So it stops short of being the right triangle. And then let's say this is still 6 and this is still 8. You can almost kind of see now the picture. Well, that's going to be an acute triangle, right? Let's see what happens with the numbers. Here's how you'll see with the numbers. 6 squared plus 8 squared equals 9 squared. I'm trying to figure out, does that work? 6 squared still 36. 8 squared still 64, and that equals 81 on the other side. And when I add these 2 together, the A squared plus the B squared was bigger than C squared. What do you know? This was greater than the 1 by itself, the C squared. This is when you get the acute case. Okay, on that last slide, then I'm going to let you try the problems and see if you can figure out which type they each are, but I'll give you a little hint on them. I also want you to copy this down on next to each one of them. That's kind of your hint for which one it should be. But here's your rules. If you're just like, Mr. Cato, okay, how do I know which one is which? Well, here's what you're going to note today. When you plug in A squared, B squared, and C squared, when you figure out which ones to plug into which spots, if you get that A squared plus B squared is less than C, then that's the obtuse triangle case. And again, you should see it for this case here. When the 2 sides added together are less than what C is, that means that C is too long. It stretched out the right triangle and made it too big to make a right triangle. So that's when it's the obtuse triangle. And maybe even draw a little obtuse triangle just to give yourself the idea of the case, right? Draw a better one than I did right there. Okay. The right triangle, that's when the formula works. A squared plus B squared equals C squared. I've got the one there in the black right behind it. So that's the one you can see. There's my right angle. So if you plug the three numbers in and they work, then you got a right triangle. What do you know? This case should be a right triangle for you when you try it out, okay? And then the last one, if A squared plus B squared, if the two are bigger than C, that's the acute triangle. Again, acute triangle looking something like this, right? All the angles are less than 90 degrees. And again, this case you should find to be an acute triangle when you plug them in. So try those out, make sure those work. And then when you try the homework, you should be using this rule as well. Use this page if you need. Or if you remember it, great, but you'll be able to tell which type of triangles that you have. Any questions, email or Zoom me.